All right, we'll go ahead and get started on the next one. So I'd like to introduce Mark Shaw and Antson. We're going to talk about the Olympus JBOF.
All right, thank you very much for coming. I know this is kind of friends and family time at OCP. Quick agenda. I'm not going to take a lot of time. I'm going to leave most of the dirty details to Antson. I'm just going to kind of quickly set the agenda. We're going to talk about Project Olympus JBOF. We're just going to give you a brief overview, a reminder of what exactly it is. And then Anson's going to kind of take over. He's going to go through some of the design tips, some of the lessons learned through the design. He's going to talk about the power consumption, thermal efficiency, and kind of draw some conclusions. And then hopefully leave this kind of open for questions. This is the first chassis that we've done with an EDSFF drive, so there was a lot of learnings to be done. I feel like Antson probably designed this thing 2 or 3 times while the EDSFF spec evolved over time. Just kind of summary reminding what it is. It's a 1U JBOF. It is a total capacity of 256 terabytes or higher, supporting Intel's supporting the EDSFF E1.L form factor, leading with Intel's ruler at 16 terabytes per drive, giving us 16 times 16 is 256. Math. It's got 2 PCIe by 16 uplinks to a head node running at PCIe Gen 3. It's got a 1 gigabit Ethernet port for management. This has a BMC, so it's managed like a server. It's got 16 slots in the front, all of them hot pluggable, all of them supporting the EDSFF 1U long form factor. We use an 18 millimeter wide version of it in order to get a little bit better thermal efficiency out of it. It's hot pluggable and front loaded from the cold aisle. And kind of the biggest probably announcement feature is that we are multi-source. So most major SSD vendors are engaged in E1.L designs. We have 1 right now. There is a second coming quickly, and there are more on the way. So this form factor is multi-source, so the risk has, I think Jason, with the sourcing risk is considerably lower right now, and the ecosystem is off to a good start, and it's very healthy. From a power consumption standpoint, we've measured the power consumption running at our maximum loads, and we're below 400 watts. So that's, to me, that's kind of justification for why is this form factor good? Because I hate to be burning 400 watts in 2U. 400 watts in 1U is a much better story for us. So with that said, I'm going to turn this over to Antson Chang from Wiwynn.
Thanks. First, thanks, Mark, to be my co-presenter for this topic. And currently, for this FX-16, this project, and we define and use the EDSFF this form factor. Even the Wiwynn's name is not listed in EDSFF their page. However, that Wiwynn already run this kind of the technical assessment from system point of view, working with Microsoft and Intel directly. So here we have some other that we would like to share this kind of information to all of you, because we are not only Wiwynn and Microsoft the FX-16 use this kind of form factor. And we would like to promote this kind of the, interface to all of you, because we see the beauty to use this kind of form factor. We got really good the thermal efficiency on this kind of form factor. So based on it, so first time, let's go into the, there are some data shows the storage chain. So about performance, then we know that SSD is quite good on the IOPS and throughput. So maybe this compared with the hard drive, then maybe that's 10 times or even 100 times better than the hard drive. About cost, normally we just say the SSD cost is really higher than the hard drive. However, that in this year, the business critical hard drive, maybe that the price is still only the 1/10 compared with the data center, the SSD. However, the mission critical the hard drive, which is listed as the 15K RPM, this kind of hard drive, maybe the price is quite close to the SSD in this year. And about the density, currently I just compare that density per 1U in terabyte. So for the hard drive, in this year, I just take the 2 the JBOF. One is the Olympus 2010. Another one is the Facebook Bryce Canyon. Even it is the storage server, then it put 72 the hard drive inside, and in 2010 it put 88 the hard drive inside. So in this year, the hard drive, maybe that the mainstream is the 14 terabyte to 18 terabyte per unit. So by this kind of calculation, so you can see that number per 1U, so it's around, maybe the maximum is around close to the 400 terabyte per 1U. But for the SSD, now in this year, we have the QLC, the EDSFF form factor, so which means that the density is highly increased. So currently, we have the 16 terabyte per device. So in FX-16, it has 16 slots, so it goes up to the 256 terabyte. But some of the vendors they decide that with 32 the SSD in a system, in 1U system, so it can up to the 512 terabyte per 1U. So in next year, the 32 terabyte, the EDSFF form factor, the SSD will be available, which means in next year, in 1U, based on the PCIe SSD, it goes up to the half to 1 petabyte per 1U. So this is the density we can see in current and in next year. So in 2016, at the moment, we just think about that SSD is really good on performance. So we are thinking about what kind of the feature we should implement in this JBOF. So we think about, we would like to have the hot pluggable, which make the Service-16 happy. And another one is the balance the airflow to enhance the thermal efficiency. And total capacity, yes, the SSD is expensive, but the capacity, could we increase that compared with the existing storage? And for the SSD, it has the high density or high performance, different kind of the drives. So we are thinking about, is that possible to support both? So do we have the flexibility to support the high performance or high density, this kind of SSD? So this is what we are thinking about and what we want. And later on, we will survey that the SSD form factor in the market. So at the moment, we can see that quite popular the device is the M.2 and U.2. However, the U.2 is put in 1U. Maybe that there are some mechanical limitation. So we are thinking about to put multiple the M.2 together. So we just think about to put that in a cage and to fulfill this kind of requirement. While the EDS of this kind of form factor comes out, we just see, okay, this kind of form factor fulfill most of, I would say, all of that requirement we need. So later on, we just pending our M.2 skill and just migrate to the EDS of SSD. So in the end of 2016, Wiwynn already worked with Microsoft to have this kind of M.2 carrier, this kind of concept. So in the same time, the Samsung and Intel have similar this kind of concept, that device. So later on, in 26, the first half, Intel invite Microsoft, Facebook, Lenovo, Samsung, these companies together and to define the new SSD form factor. So it is called Enterprise and Data Center SSD form factor, EDSFF. So in last year Q1, then the FX-16, the first prototype was ready and demonstrated in OCP booths. I think it is in both that Microsoft and Wiwynn's booths. So in this year, this Q2, FX-16 is ready for mass production. Later on, maybe you are thinking, you might ask, I just heard that the EDS of the form factor, but I see lots of that different kind of form factor. So I list all of them. There are 8 kind of the SSD form factor. So, and what we used is 1U long and 18 millimeters width, this kind of form factor in FX-16. So later on, let me share some design tips and using this kind of the form factor. So for the system implementation, we know that I just list 4 of them here. Because normally we would like to support the front access. Sometimes we will design it as a back plan. But however, the back plan will block the airflows. So at the moment, we just think about, is it possible to design that as a riser, or we call it the paddle car, this kind of design. And it can have the clear airway and enhance the thermal efficiency. And And at the moment, we just choose SMT, the existing connector, to implement this kind of concept. So it is easier for component placement close that connector and the better SI, because that if we use the press fit or dip type, the through hole type, it will have the long stop, and you need to have the back drill, this kind of the process to make sure the SI performance get what you need. So based on this kind of concept and by our simulation, we just found even we can support it to PCI Gen 4 or even Gen 5. So this is also the connector is available. So, but by this kind of design, it will make the mechanical design and system assembly process is a little bit difficult. So here comes two options for your implementation. So currently there are the connector vendors comes out. There are two kinds of orthogonal connector. One is press fit type. Another one is SMT type with assembly. So this is already for the press fit type. I think it is already mass production now. So you can leverage it for your design. But however, that currently because it's press fit, so from our point of view, and that back drill might be needed to support up to the PCI Gen 4. But for the SMT type, currently we see most of the feature is positive. But however, that tooling is will be ready in this Q2. Next, we would like to share some mechanical the design. So the E1L, the EDSFF, the one you long, this kind of definition, it supports that you can have the customized the extension kit, or we call it latch kit, for your existing. You can align with your existing panel looking. So this picture shows what Wiwynn work with Microsoft and to define that the extension kit looking, and we use the two screws to fix together. And for the blind matting, so we suggest to have the guiding rails and mechanical stoppers, because the EDSFF is used the PCI golden finger to contact with the connector. So the connector and golden finger is just for signal transition, not absorb the insertion force. So please make sure the guiding rails and mechanical stopper is implemented in your system to make sure it is not, the connector is not damaged by your operator or engineers. And next one is the latch. So the latch design is quite important because the short pin of the EDSFF connector is only, the connector contact with the short pin is only 1.7 millimeter. So the mechanical design tolerance management is quite important. So because if you did not control that well, then maybe you will have some kind of design after shock or vibration or transition, the device. Next one is, we suggest to have the shorter design in your chassis to make sure that it will block the air while the SSD is non-populated. For the mechanical design, then first one is, we would suggest to have the isolation for slots, between slots, because while we plug in or plug out, sometimes we will create the glitch on sideband signals or power. So it will make the existing SSD have some incorrect behavior or unexpected event you don't want to have. So we would suggest to have the isolation for between slots. And for the power enabling inrush current protection and overcurrent protection, these three items is quite common for the hard plug, this kind of the device, no matter in the JBOF, it exists in the JBOF or hard drive. However, compared with the EDSFF pin definition and hard drive, there is one pin have been removed, which is the pre-charge pin. So without the pre-charge pin, while sometimes the power is still enabled, while we push in that hard drive or the SSD, you will see the inrush current. So because of this, so we got the lesson learned, and we suggest you to have the power enabling should be based on the present pin to make sure there is no unexpected that plug in and make you the inrush current damage your SSD. Next one is SMbus access. For the SSDs, it can support the I2C or SMbus to access to get the through or that VPD information and before you initialize it. However, currently the industry standard did not clearly define how much time we should wait before the access. BMC maybe can get that information about presence, but how much time we should wait, currently there is no defined. Some of the vendors, they tell you maybe 20 seconds, but some of them, they tell you in the failed event, then reinitialize, it take more time. Maybe you should need wait 1 minute. Currently, there is no clear define. So here's I list here. Maybe there are software members, you know that. So sometimes you have to walk around to support the SSD vendors because there is not they have a different initialized time for the controller. And EDSFF also support the dual port. So of course we know that for the dual port we will have the clock and the preset for the port B. And sometimes we will implement that, use the GPIO expander or CPLD to control that to enable the dual port or disable the dual port function. So please make sure we have already pulled down the dual port enable pin before enable the SSD power. And make sure which pin connects to the port B. I just use the blue color to highlight that this lens is connected to the port B. Later, I just show some data about the power consumption and thermal efficiency. So this is the data test with test on FX-16, and the first column shows that stress 2, we use the disk speed, and there are 3 different kinds of the sequence write the percentage, and you can see these code pictures here, and I just list 2 conditions. First one is the ambient in the 25 degrees C. Another one is in the 35 degrees C. So because the company, you have the different kind of mass to calculate that efficiency. So I just list the system fans, PWM, airflows, and power here. So you can based on it to calculate that if you have your data, you can compare with this table and to see the efficiency on your device and in FX-16. So in our FX-16 in 25 degrees C, so for all kinds of that, the stress percentage is around 70 CFM per kW. And in 35 degrees C, it runs up to 110 to 120 CFM per kW. So this is the test result we have now. But let me share 2 more information. So I just list, I also have another data shows that existing JBOF, OCP JBOF, which is from Facebook. So the CFM per kW in 25 degrees C is around 100 in 25 degrees C. And in 35 degrees C, it's 160. So which is much higher than what we have on this device. And we also have the data on Facebook, another project, Price Canyon. So the CFM per kW, it is the storage server. It's kind of a little bit different, but I also have the data. So the CFM per kW is about 110 in 25 degrees C. And in 35 degrees C, it's about 160. So compare with the JBOF or JBOT in the market now, so we have the 30% the thermal efficiency better than then. So here comes the conclusion. So EDSFF, this kind of form factor, provide the front access and hard plug this kind of capability. And you can, based on it, to have the high density design and make your thermal design more efficiency. And it is also scalable to support the PCIe by 4, by 8, or by 16. And it will have the feature. It has the feature to support a single port or dual port. Even we asked the vendor to about this feature readiness, but they told us it will be ready in 2020. So and the same connector definition, it can support to the PCIe Gen 3, Gen 4, even Gen 5. So this is what we see the beauty for the EDSFF. So here comes another slogan: join us to use EDSFF for the next decade for SSDs. So here's my presentation. Thank you. So, any questions?
We have time for a couple of questions if you have questions. Okay, if we don't have any questions, so let's just thank the speaker again.